Alright guys, so we are working on 42 through 60 evens of your midterm review. This next section is asking us to solve inequalities. You're going to solve this the same way as if you would, if this was an equal sign. The only difference is, whenever you're finished, if you ever divide or multiply by a negative, this inequality sign will switch. Okay? So the first thing I'd want to do is go ahead and distribute here. It's not the first thing you have to do, but it's a good idea. Negative 5 times x is negative 5x. Negative 5 times negative 5 is a positive 25. Then everything else stayed the same. From there, I would want to move my whole numbers over to the right, so I'm going to subtract them to cancel. Whatever you do to one side, you have to do the other. So 50 minus 25 is 25. You've got negative 5x. From here, to solve for x, you would divide by a negative 5. Remember, whenever you divide or multiply by a negative, and it goes across that sign is going to flip like that. And then your x is left. And then 25 divided by negative 5 is negative 5. That would be your answer. Number 44, same concept. You want to get all your x's over to one side and all your whole numbers over to the other. I'm going to move my x's to the left because in inequalities, when your letter is on the left, it's easier to graph. So I'm going to subtract 8x, cancel, subtract 8x on this side. And I notice they both cancel. So now I'm just left with 9 is less than or equal to negative 10. We know that that's not true because 9 is greater than negative 10. So in this case, there's going to be no solution, or you could call it false. We also talked about how we called that a false statement. Thank you. Number 46, it's asking me to find the product, so I'm going to multiply. This is where we would use FOIL. First times the first. 4s times 4s is 16s squared. Outside times the outside, 4s times 1 is plus 4s. Inside times the inside is negative 4s. And then the last times the last, that negative 1 times positive 1, which is negative 1. You want to combine your like terms here. 4s minus 4s, cancel. You're just left with 16s squared minus 1. Turn in the next page. Number 48, we still want to find the product. So here, you're taking m minus 5 and you're squaring it. Well, we still want to FOIL, but in order to FOIL, you have to rewrite this twice. So you want to write it m minus 5 times m minus 5, like that. Then we do the same process that we just did. First times the first is m squared. Outside times the outside is negative 5m. Inside times the inside is negative 5m. And last times the last. Negative 5 times negative 5 is a positive 25. From here, you want to combine your like terms. Negative 5 minus 5 is a negative 10m. So I'll have that plus 25, you still have that m squared. That would be your final answer. We're going to graph some inequalities. This might be something you might do after a problem like we did in a previous section, where you get the answer is h less than or equal to 7. And remember I said whenever the letter is on the left, it's easier to graph. That's because this symbol right here can be used like an arrow. It tells you which direction to shade. So we put some numbers on our number line. I'm going to put 7, I'm going to put 1 above it, which would be 8, and 1 below it, 6. And this sign, whenever it's less than or equal to, it's going to be a solid dot on the 7. If it was just less than, then it would be an open dot on the 7. Then it tells me to shade that direction, so I just point my arrow to the left. H is less than or equal to 7. Number 51 and 52 are asking for the equations of vertical and horizontal lines. Remember that vertical lines are always written as x equals, and horizontal lines are always written as y equals. I know you might think that's backwards because of the x and y axis, but that's what you want to memorize. Vertical lines are x equals, horizontal lines are y equals. And in this case, y equals the 2, so my line, the equation for my line is y equals 2, because that's where he is on this point. This is the x and this is the y. Okay, we're going to go ahead and turn the page to number 54. Factoring. Remember when we are factoring, we use the x, and we use the table, and then when we have a is greater than 1, we go ahead and break it down into the window. So here, this a term is greater than 1, so we're going to break it down into the table. Remember, a times c goes at the top, b goes at the bottom. 3 times 2 is 6. B is 7. So I'm thinking what multiplies to give me 6 and what adds to give me 7. So you could do 1 and 6 or 2 and 3. But this pair is the one that adds to give me 7. So from there I take my numbers here and they make it into this window. I put a here, so this is the 3x squared. I split the b up from 7x into 1x and 6x. And then my c comes down here as 2. And you look for your greatest common factors in each column and then in each row. So for this column, the greatest common factor is just 1. Because that's all that 1 and 2 have in common. Then I go to this column, and in this column they have a lot in common. They have a 3 in common, because 3 can be divided by 3 and 6 can be divided by 3. They also have an x in common. Then you look at your rows. 3x squared and 1x, they just have a 1x in common. And then 6x and 2, they can both be divided by 2. So this is where you get your parentheses. Now you've got 3x plus 1 as one of your sets of parentheses, and 1x plus 2 as another set. So that would be your answer. 3x plus 1 and 1x plus 2. Number 56, we're going back to graphing quadratics. There are some steps here. Number 1, always start with the axis of symmetry. Then number 2, plug in to find your vertex. Number 3, use the y-intercept. And number 4, when all else fails, go ahead and pick points and plug them in. So the first thing I want to do is the axis of symmetry. Remember that that formula is opposite of b over 2a. So this is a, this is b, and this is c. So the opposite of b is going to be a negative 8 over 2 times negative 1, because a is negative 1. So you get negative 8 over negative 2, which simplifies to 4. So I can go to the axis of symmetry spot, and I can write x equals 4. Don't forget to write it like x equals a number, because that's your vertical line for your axis of symmetry. So I'm going to go ahead and graph that as a dotted line. From there, I use x is 4, and I plug it into this equation in order to solve for y. So I'm going to rewrite that equation, and wherever there's an x, I'm going to plug in a 4. times 4 minus 10. Instead of writing that x, you want to write 4. And what I would do is just plug this into your calculator all at once, making sure you have parentheses around your 4. Make sure that that negative sign stays outside the parentheses because he is outside of the x. That's 8 times 4 minus 10. I don't know if you can see my calculator, but that's what you'll want it to look like. Negative on the outside of your parentheses. Hit enter. It gives you the answer, 6. You have positive 4 as your x, and the y is 6. So you want to go positive 4, positive 6, and that is your vertex. Step number 3, use the y-intercept as a point. So my y-intercept is always the c, so I go down to the negative 10, and I know that's going to be a point. I can reflect him across and get another point. And when all else fails, I can pick a point. So let's say I want to pick, I don't know, 3, positive 3, because I know that it would be somewhere in here. So what I would do is go back to my calculator. You guys can see that. And hit second, enter, in order to bring up my equation with the 4s. And wherever there's a 4, I'm going to plug in the 3 now. Hit enter, and I got 5. 3, 5 is a new point. And that's just a point that I came up with. You could have picked a different point. You could have picked 1 or 2, but you'd want to pick something in between the 2 points you already had. Now that I've got 3, 5, you want to reflect him across, and you've got all 5 points. Okay. Now I can continue filling in my information. It asks if it's a maximum or a minimum. So you want to look at your vertex and say, is that the highest most point or the lowest most point on my graph? In this case, it's the highest, so that would be a maximum. My graph opens down like a sad face. The domain for all your quadratic equations is going to be all real numbers, and then your range is going to have something to do with the y values. So look at your y values. They're going to start here at 6, and then they are going to be all less than, because less than goes down, so my y's are all less than or equal to 6. And you will always see the y of your vertex in your range. And you'll just need to compare, are the y's getting greater or the y's getting less than? Okay. Number 58 and 60 are our last two problems, and those are what we did for this last unit. So number 58, we are writing radicals in the simplest form. Remember, in order to subtract, you have to have like terms. So the first step here is simplify your radicals. Second step, combine like terms. So my first step is to simplify the 50. He breaks up into 2 times 25. 25 breaks up into 5 times 5. Remember, buddies get to break out of jail. So that 5 gets to come out. Inside the radical, I have a 2 that's left. Then I'm going to draw a little line here so I don't get confused with my next radical that I break up, because they don't go together. 75 can be broken up into 3 times 25. 25 can be broken up into 5 buddies. Notice that 5 is coming out, and the 3, the negative 3, is already there. So remember, when you have two numbers outside of jail, they multiply. So you get negative 15 on the outside, and then your 3 is stuck in. That last one I need to break down, I can break down into 3 times 9. 9 breaks up into 3 times 3. So your 3's get to come out of jail. They're going to multiply with that negative 3 to get negative 9 radical, and then your 3 is stuck in here. So my new problem looks like this. 5 radical 2 minus 15 radical 3 minus 9 radical 3. You want to combine your like terms. So these two look alike. They have radical 3s. So negative 15 minus 9 is negative 24 radical 3. And don't forget this 5 radical 2. He comes down as well. And that would be your final answer. Problem number 60 is asking me to solve using the quadratic formula. Go ahead and write the quadratic formula down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the first step is to label your a, b, and c, a, b, and c, and then plug into your equation. The opposite of b is going to be a positive 9 plus or minus the square root of b squared. Well, in this case, b, negative 9 squared is going to be positive 81 minus 4 times a times c all over 2a. You just want to simplify from here. The first place to simplify is this multiplication inside your radical. Negative 4 times negative 4, which is 64. And it's going to be a positive 64. So I'm just going to write plus 64 to remind myself that inside my radical, I want to add 81 plus 64. So inside my radical, I'm going to get 145. All over 2a. 2 times 4 is 8. One of my last steps here is just to make sure I can't simplify that radical. I know I can break up 145 into 5 times something. So I'm going to divide it by 5 and see. 5 times 29. But 29 can't break up into anything. That's prime, right? So from here, you're done because you can't break your radical up. You can't simplify it. So this is your final answer. That's it for the review videos. Hope that helps. Come into tutoring if you need any further assistance.